Number Theory, Section 4, Diophantine Equations. Video 4, Pell's equation for square n. In the last video, we looked at Pell's equation, x squared minus ny squared equals 1. Here we're going to look at what happens when n is a square number. So for example, we might look at Pell's equation with n equals 4, x squared minus 4y squared equals 1, with x and y greater than or equal to 1. Now we can use our code from the previous video to look for some solutions for this, and we're going to look for solutions up to 1,000 first of all. So here's my function for Pell's equation, and I want to know what happens if I work out Pell's equation with n equals 4 going up to a maximum of 1,000. And very quickly it's shown me that there are no solutions in that range. I might try to increase that range a little bit and say, what about solutions up to 2,000? And it took my program a little bit longer, but it still hasn't found any. I could look for bigger numbers still, but the bigger the number, the longer it's going to take me to return it. And I'm starting to suspect that perhaps I'm not going to find any solutions anyway. So let's see if we can prove that. So I want to prove that if I have x squared minus ny squared equals 1, and n is a square number, let's say that n is m squared, that there aren't going to be any solutions in the range x greater than 1, y greater than 1. So let's see what happens. I could try using the difference of two squares. So let's rewrite this as x squared minus m squared y squared equals 1, and then x plus my times x minus my equals 1. Now what I've got here is x is greater than or equal to 1, y is greater than or equal to 1, m is some whole number here as well. Everything is a whole number, which means that these two numbers both have to be two whole numbers that multiply together to give 1. The only pair of whole numbers I'm going to have that multiply together to give 1 are 1 and 1. So that means that I have my first bracket x plus my equals 1, and my second bracket x minus my equals 1. Solving this pair of simultaneous equations gives me 2x equals 2, so x equals 1, and I have this trivial solution where y equals 0. So apart from this trivial case, there are no other solutions. Let's look at that written out neatly. So considering x squared minus ny squared equals 1 with n equal to m squared, then I've got x squared minus m squared y squared equals 1, which can be written as x plus my, x minus my equals 1. Since everything is integers, then I need to find two integers whose product is 1, so that means that x plus my has to be equal to x minus my, which is equal to 1, and this yields the trivial solution y equals 0. In this video then, we've investigated Pell's equation when n is a square number. We found out using our program that there were no solutions, and then we proved that there is only the trivial solution y equals 0 when n is a square number.